full wave bridge rectifier. So bridge rectifier means a circuit frequently used for electric DC power supplies. We call it as bridge rectifier. Now here in bridge rectifier, as input we are using AC. This is the transformer, right? Now next, here we are using 4 PN junction diodes, D1, D2, D3, D4. We are using 4 PN junction diodes. This is the load resistance where we find the voltage drop. Okay, and now this is the circuit diagram of full wave bridge rectifier. Now let us see how it works. Now here as input we are giving AC, okay, which is nothing but having positive cycles and negative cycles alternately. Okay, so now here in a positive cycles of AC, in a positive cycles of AC, M becomes positive. These are the two terminals, M and N are the two terminals. Okay, so for this M becomes positive, right? N becomes negative. Okay, for positive half cycle of AC, M becomes positive, N becomes negative. So M became positive now. So now this diode becomes this side positive, this is positive, alright? So now this becomes negative and this becomes negative, and here this becomes negative. Now this one also becomes negative, N terminal is negative, this becomes positive and this side becomes positive. Now see the diagram. Here if we take D1 diode, positive terminal is for P of the junction diode, right? So D1 is forward biased. Now if we take D2, so here to P negative terminal is there, so D2 is reverse biased. Now if we see the case of D3, again for P we got positive terminal, so D3 is forward biased, and for D4 diode again P is having negative terminal, so it is reversed bias. So here what is happening? Now for positive half cycles, M became positive, N became negative. Okay, so here D1, D3 diodes are forward biased, and D2, D4 diodes are reversed biased. So current conduction is due to D1 and D3. So in all positive cycles the current conduction will be due to D1 and D3. So now this is the output waveform due to diodes D1 and D3. Okay, this is the output waveform due to diodes D1 and D3. Okay, diodes D1 and D3. Now let us talk about negative half cycle. Okay, now let us talk about the negative half cycle of AC. Negative half cycle of AC, this green color. Alright, now for this what is happening? Now here M becomes negative, N becomes positive. Right, now let us move towards the circuit. What happened? M became negative, right, and N became positive, right? As M is negative, what happens? Here we get negative, negative. So here it will be positive, and here it will be positive. Now here N terminal is positive, so this is positive and this one is positive, and other side is here negative and this is negative. Now see here for D4P we got positive terminal, so D4 is forward biased. Now if we take D1, here P is negative, so it is reverse biased. Now let us see D2. P became positive, so it is forward biased. Now next for D3, now P became negative, so reverse biased. So here what is happening? Here D4 and D2 are forward biased. D1, D3 are reverse biased. So current conduction is due to D4 and D2 diodes, right? And this is the waveform, this green color waveform due to D4 and D2 diodes. Now this is complete waveform. Okay, now let us see current direction. Now here we draw complete waveform in same direction. Now let us see that direction of current. So first let us see the direction of current in case of positive half cycle of AC, where D1 D3 became forward biased. Okay, so D1 D3 means here M terminal became positive, no? So now this solid arrow indicates the current direction. From M it starts. Okay, from M here it is moving towards A, and then it is coming towards B. From B, now see, this is the solid arrow going towards C. From C again it is going in this direction towards E. Okay, and from E again it is going towards F, and from F again it is going towards N. So current direction is M, A, B, C, E, F, N. Okay, the current direction is M, A, B, C, E, F, N. Okay, now here at load resistor, current, this solid arrow you see, current is from B to C, right? Now in case of negative half cycle, D2 and D4 are forward biased. So D2 and D4 are forward biased. Now here terminal N is positive. So here let us see the current direction. So current direction for this will be current direction. It starts from N. Okay. So you see the dotted line arrows. Okay. So N to F. See, this is dotted line arrows. N to F. Okay. Now next from F it is going to B. N to F. F to B. From B you see dotted line arrow. To C it is coming. Okay. Again to C it is coming. Again from C it is going towards E. Okay. This dotted lines you see, in such a way it is going towards E. And from E where it is going? It is going towards A. And from A again this is moving towards M. Right? So the direction is N, F, B, C, E, A, M. Now here from B to C let us see. This direction of current due to diodes D2 and D4 are also from B to C. Direction of current due to diodes D1 and D3, which are forward biased in positive half cycle, is from B to C. Similarly, the diodes D2 D4 when become forward biased in negative half cycle of AC is also from B to C. Means both current directions are from B to C. So only now output waveform will be in same direction we draw. Now this is the total output waveform due to bridge rectifier. Means here it is functioning similar to that of the full wave rectifier. And advantages means here we don't need any center tap for transformer. Okay, we don't need any center tap for transformer. Now this is about the working of full wave bridge rectifier. Now if we go for the mathematical part, again it works the same as that of the half wave rectifier. So IDC for a half wave rectifier, what it was? 2m by pi, right? Now IRMS, Im by root 2, VDC to Vm by pi, and efficiency 81.2%. Means it works the same as that of the full wave rectifier, but here there is no need to have center tap transformer. So this is about the bridge rectifier.